There's something deeply weird about the internet today. Beat. Building a cinematic, 3D interactive website used to require massive teams.
Oh, absolutely
The
massive.
entire departments of developers were needed for the absolute basics. You needed designers, front-end engineers, and rendering specialists.
And a huge budget.
Right. But today, it just takes one single image. One image and, the right conversation. Welcome to the Deep Dive. We are unpacking a step-by-step masterclass for you today.
It is going to be a fun one.
We are building a scroll-controlled luxury web animation completely from scratch.
Yep, and the project is a fictional live watch called The Abyss.
We're going to go from a completely blank screen to a deployed website, and we will use GPT-5.6 Sol. That is an advanced AI that generates text, code, and images.
And the best part is, no coding is required on your part at all.
That is exactly right. The whole process is absolutely fascinating.
We are essentially acting as visionary directors for this powerful AI. We are guiding it to build an entire digital world.
It is kind of like having a world-class film crew and coding team waiting for your instructions.
Right, but you have to know exactly what to tell them.
Exactly. You cannot shoot a great film without a really solid script.
No, you definitely cannot.
Before generating any code or pixels, we must architect a story. You have to plan the emotional journey for the user first.
I was thinking about this earlier. We really have to push the AI beyond its safe defaults.
Oh, for sure. If you just ask for a website, it gets lazy.
It really does. It is going to build a normal landing page with generic sauce feature cards.
I mean, it kind of lacks soul, and
And feels incredibly predictable to the user, yeah.
AI models are trained on average web data, right?
Exactly. They naturally default to boring, predictable web layouts.
Yeah.
You have to fight that statistical average immediately.
So we want a 4-scene scroll story for a 3,000-meter dive watch.
Scene 1 starts with the watch above the ocean at night.
In Scene 2, it physically breaks the water surface.
Scene 3 takes us down through darker layers toward 3,000 meters.
In Scene 4 is a dramatic camera zoom directly to the watch face.
We are treating the web browser like a true cinema screen. We are basically pulling the user downward into the dark ocean.
You have to demand a dark ocean visual direction from the very start.
Right, you want minimal typography, deep blue lighting, and slow, controlled movement.
The website must include one unforgettable moment that makes visitors stop scrolling.
You really need strict directorial control over scale, depth, and visual transitions. Otherwise, you just get floating UI panels and standard feature grids.
Let me pause you there for a second.
Sure.
Why not just ask it to build a cool watch site from the start? Why do we need this rigid 4-scene breakdown?
Well, because AI does not understand narrative tension on its own. You must tell the AI exactly how the background and lighting change.
You define exactly when the text appears and disappears in each scene.
Yeah, you even dictate which specific product detail is introduced. You do not let the AI guess any of these crucial details.
If you let it guess, it ruins the luxury aesthetic immediately.
So
So how do you actually ensure the AI understands this story structure?
you feed it the entire scene-by-scene breakdown before writing any code. You define the exact scroll actions and lighting changes up front.
You make the AI plan the script before it codes?
Precisely. Now that we have our script, we need to cast our lead actor.
And we must keep that actor consistent across every single scene.
We use the AI to generate one singular source of truth image.
I gotta say, this part is always so chunky. I still wrestle with prompt drift myself.
Oh, prompt drift is a massive headache for AI directors.
It is just so hard keeping AI from changing designs between scenes.
Diffusion models just predict pixels. They do not actually understand 3D geometry at all.
If you generate a new image for Scene 2, everything changes.
Exactly. The luminous markers might shift or the titanium texture changes completely.
Locking in one single image is vital for visual consistency. So we create one perfect image and let the code move it.
Right. The prompt details must be incredibly precise for this to work. We ask for a premium brushed titanium case and a deep black dial.
We need blue-green luminous markers and a dark navy studio background.
It must look exactly like a high-end luxury watch campaign.
Notice we are not putting the watch underwater just yet. We are keeping it in a sterile studio environment for now.
Exactly. We want an angled front view to show the case depth.
This angled view reveals the strong architectural bezel and dark titanium bracelet.
Crucially, you must leave empty space around the watch. The camera needs that empty room to move during the scroll.
Right, if you crop it too tight, the animation will feel terribly claustrophobic. We want cold blue light reflecting directly across the metal surfaces.
It must have fine product details that remain sharp during close-up shots.
You refine this one image until the titanium texture feels perfectly realistic.
You also tell the AI to increase separation from the dark background.
You reduce any heavy reflections that might hide important product details.
The watch must remain clearly separated from the surrounding shadows. It needs to pop off the screen when the user scrolls.
But why aren't we generating multiple angles of the watch?
Well, generating multiple angles almost always changes the small material details. The watch design will inevitably shift between those different views.
One perfect image prevents the watch design from changing entirely.
Exactly. So we have the script and we have the star actor. Now we feed the mega prompt into the exact same AI conversation.
This ensures it remembers the story and the original watch image. We are moving from the planning phase to the building phase now.
The AI uses tech like WebGL and 3JS for this.
Those are tools to draw 3D graphics in a web browser.
Right. It basically turns your browser into a mini video game engine.
It also uses GAP scroll trigger to control the overall pacing. That is code that links animations to your mouse scrolling.
It connects every visual change to your exact scroll position. The specific scene mechanics here are just incredibly complex.
The depth meter ticks from 0 to 3,000 meters as you scroll.
You see realistic water distortion when breaking the ocean surface. Text fades in and out at precisely the right moments.
The whole animation reverses perfectly when you scroll backward.
It creates a very slow and controlled feeling for the visitor.
Let's talk about the psychology of that first scene for a minute.
Sure.
The experience begins in almost complete darkness. A distant point of light slowly becomes visible above the ocean horizon.
As you scroll, the camera moves toward the light to reveal the watch.
The movement is calm, letting the camera create most of the scale change.
The watch grows from a distant object until it fills the screen.
Then in scene 3, you keep the watch visible during the deeper descent.
You introduce product details like the brushed titanium case and sapphire crystal.
You show one detail at a time, removing it before the next appears.
It respects the user's cognitive load and keeps the focus tight.
What is really fascinating is the background depth mechanics.
Oh yeah. The ocean layers actually move at entirely different speeds while scrolling. This creates a profound sense of three-dimensional space.
It is a technique called parallax, and it completely tricks the brain. Whoa. Imagine generating that physics engine from a text prompt. 2-sec silence. That sheer processing scale is genuinely hard to wrap my head around.
It really is wild.
The AI is building complex parallax scrolling just from our instructions. But what are the main technical limitations in this first build?
The first pass usually struggles heavily with timing and visual pacing. The animation might move too fast or feel quite empty visually.
The first draft is functional, but needs serious visual pacing work. We're going to explore exactly how to fix that pacing right after this. Mid-roll sponsor read, placeholder.
And we are back. So we have this raw footage, so to speak.
Right.
The first build is functional, but the pacing feels entirely wrong.
Right. And the first build will likely feel too fast or visually empty. You have to fix this in a very exact order.
You cannot just randomly ask the AI to make it look better.
No, first, you must address the watch movement itself. You slow the watch down and give it some real weight.
It should not float or spin around without a sense of gravity. This is a really crucial point. We are not just blindly asking the AI to improve the site.
We ask it to review the current experience before editing anything.
Yeah, you ask the AI to identify where the experience feels flat.
It highlights exactly where the animation moves too fast or feels empty.
Then you explicitly command the AI to keep the watch near the center. You use small vertical movements to support the feeling of the deep descent.
Before every major transition, you hold the watch in place for a moment.
This creates a much-needed pause in the overall visual pacing.
It lets the user appreciate the luxury details before moving on.
Second, you build the background around that refined watch movement.
You add the dark ocean layers and large, soft ABYS lettering.
You introduce underwater light, soft fog, and restraining bubbles.
The near layers should move slightly faster than the watch itself.
That is exactly how we reinforce that deep parallax effect we discussed earlier.
The distant background layers should barely move at all.
Right, exactly.
Yes.
Third, you finally adjust the typography to fit the new composition.
Text must never cover the watch details under any circumstances.
You only show one foreground text element at a time on screen.
It might say something like, titanium, pressure tested, uncompromised.
Each line must disappear entirely before the next one appears.
You have to maintain that quiet, isolated feeling of the deep ocean. It is like stacking Lego blocks of data.
That is a great way to put it.
You have to fix the foundation of movement before adding the roof of typography. Why is it so crucial to control those text reveals so strictly?
Because text competes directly with the product for your viewer's attention. If a headline overlaps the dial, the luxury feel evaporates instantly.
Text must never distract from the premium product experience itself.
The film is edited perfectly at this exact point. Now we add the special effects and premiere it to the world.
We introduced a 360-degree rotation of the watch.
This rotation is linked smoothly to the downward scroll journey.
You want the 360 rotation to feel premium and controlled, not fast or playful.
You slow the rotation temporarily during key scenes to keep the dial readable.
The luminous details must remain visible during the important product-focused moments.
We also blend an explorer visual mood into the deep background.
This means antique maps, compass geometry, and warm bronze detail. Wait, hold on a second.
Yeah.
Does adding antique maps to a modern titanium watch ruin the sleek vibe? I feel like those styles might clash pretty heavily. Cold metal and warm paper usually make a terrible combination.
Not if you blend the visual moods very carefully. It provides a warm, premium contrast to the cold, dark ocean aesthetic.
Oh, I see.
It creates visual depth without making the screen look too busy. The background carries a refined explorer identity instead of becoming plain black.
That makes sense. You let the light from above fade as the visitor goes deeper.
You use moving particles and layered depth to increase the feeling of vast space.
In the final scene, you keep the background dark and incredibly dramatic.
You use a slow, close approach toward the watch near the very end.
You reveal the important watch details in a cinematic way before the call to action.
The Explore the Abyss button only appears after the final reveal settles.
Finally, you ask the AI for a downloadable ZIP file. It contains all the HTML, CSS, and JavaScript files you need.
You drag that ZIP directly into Netlify.
That is a service that instantly turns files into a live website.
You publish it globally without ever touching a command terminal.
It is a massive leap forward for web development workflows. But what about deployment security, or the actual file structure?
The AI handles the relative file paths and all the asset linking. Netlify secures the hosting automatically, making the deployment process totally seamless.
The AI builds the structure, and Netlify secures the hosting.
Zooming out for a second, we really need to look at what this process means. A premium digital experience does not come from aggressive visual effects.
It does not come from throwing every possible animation at a wall.
It comes entirely from rhythm, depth, and strict visual control.
AI is an incredibly powerful developer right now in this space. But it still requires you to be the visionary director holding the reins.
You have to hold it to a strict creative standard every single step.
Think of a high-end product that you absolutely love. It could be jewelry, a camera, or a fictional invention.
Try mapping out a 4-scene cinematic descent for it yourself.
If one image and a conversation can build an interactive 3,000 meters cinematic descent today, what happens when we can prompt entirely new, breathing 3D worlds in real time?